There we go. Okay, we're up now. All right, page 144 in your textbooks, and we had some homework last night going over some of the stuff that we covered before, but also a little bit of review in the homework as well. Problem number 5. We've been working so much with compound inequalities. I wanted to make sure we worked with some that weren't necessarily compound inequalities. Problem number 5 on the homework section, the review section there. Kyla, what do we have to do on the left-hand side of the inequality?
We have to distribute.
To get?
3x negative 15.
Now we're going to keep the greater than symbol. Then we distribute again, Curtis. I'm sorry, I'm used to Curtis being over there. Sorry, Curtis. He's Everett. You're at Fine Arts. Okay, Everett.
You distribute the 2 to everything to get 8 plus 6x negative 8.
And we'll hold on to that negative 8. Now, very conveniently, class, we can cancel the 8 and negative 8. We also see we could get rid of the little x. And again, my strategy I mentioned yesterday, we want to get rid of the little x so I don't have to divide by negatives. I don't have to flip stuff around. That's annoying. So I get rid of, class, the
3x.
by making it a...
Negative 3x.
And that's going to give me what now, Kyla?
Negative 15 is greater than 3x.
And therefore x is?
Negative 5. Greater than 3.
Put a greater than symbol. Negative 5 is greater than x, or if you want to look at it from this perspective, x is less than negative 5. You could write it that way. I'm inclined to leave it just like that. Is that what you had, Kyla?
Yes.
Good. Questions on that? Looking at number 6, talk me through this one. Everett?
You need to distribute 3x plus 12 negative x is greater than or equal to 5x minus 3. And then you need to get rid of the little x. Oh wait, hold on. You can combine.
Good. We want to combine before we get rid of the little one.
To get 2x plus 12 is greater than or equal to 5x minus 3. And then you can get rid of the little x, which is the 2x, it's by subtracting it from 5x to get 12 is greater than or equal to 3x minus 3.
Good. I would like to, when I move the x over, I'd like to move the 3 over at the same time. You don't necessarily have to. It's just the lazy nature of me would love to.
Okay, and then you have 15 is greater than or equal to 3x. And then you can divide the 3 away to get 5 is greater than or equal to x.
There we go. Or if you wanted to, you could say x is less than or equal to 5, but we'll just keep it this way here. Is that what you had for that one, Kyla?
No.
All right, question, comment. Did you figure out what happened?
I didn't add the 2x's together at the start.
Okay.
And I had the...
Did you get rid of them each separately?
I don't know what I did, honestly. Because I got a 3. I got 9.
Oh, when your 3 came over, yeah, you did pull the 3x over to get 2x, then you brought the 1x over as a positive to negative with the 3x. So you moved them separately, which was fine. Problem is when you moved the 3, you forgot to make it a positive.
Oh, okay.
That's all that happened. All right, looking at number 7. And no parentheses to have to distribute this time. Kyla, walk us through number 7.
What's that? 15 by 2.
Now let's just knock out the fraction and make our life a little bit easier here.
Negative x plus 14 is less than or equal to 6. And then you can double switch.
I like the double switch, yes. Pull the x over and send the 6 over.
8 is less than or equal to x.
And we're done. Now again, do you have to do that? No, you could subtract the 14 to get negative x is less than or equal to negative 8, and then change all the signs to get x is greater than or equal to 8, but x is greater than or equal to 8 is already there faster with the double switch, so I like that. Questions? All right, and then Everett, if you'll take number 8, we had a negative x thirds plus 7 is less than or equal to 9. And you could go in a little bit different order than Kyla did if you wanted to. It's up to you.
Could I multiply everything by the LCD?
You could, and that's what she did. You don't necessarily have to do that. If you'd rather, you could start by getting rid of the 7, because there's not multiple fractions, right? There's only the 1. And so I could move the 7 over first as a
Negative 7.
to get
Negative x thirds is less than or equal to 2.
Now, in Kyla's case, she would have created a negative if she'd done that, and maybe she would rather not mess with a negative. Maybe it's just she hates fractions so much she just wants it gone. Either way, it didn't make the problem hard, let's be honest. But it's an alternative way too, to is ditch the 7 first, and now I could actually get x by itself in one step.
Multiplying by the reciprocal,
Which is,
negative.
negative 3.
Over x.
If I multiply, well, not over x, which is negative 3 over 1, right? So negative 1/3 technically, that's with the x, so multiply by negative 3 over 1. If I multiply both sides by negative 3, this negative 3, and the denominator, which is practically negative 3, right? Just with the negative pulled out to the front, like we talked about in the fraction chapter, gets the x by itself. Over here, I multiply by negative 3.
And you get negative 6.
But anytime you multiply or divide by a negative, we have to,
Flip the inequalities.
and there we go. Okay, so it's just an alternate approach to the same type of problem, but it's something we could do. Kyla, did you get this answer regardless of the way you approached it?
I had -7. I don't know why.
Oh, sadness. Okay. You multiplied everything by the negative, or by 3 right away, right?
Yes.
Did you get negative x plus 21 is less than or equal to 27? Or was one of these numbers off?
No, I had all of that.
You had all of that, and so you moved it, you double switched again, didn't you?
Yes, it looks like it. I think.
So you just got, instead of negative 6,
I got it.
you got negative 7, and then you got your x. So yeah, just careful on your subtraction then. All right, well, let's go on to numbers 9 and 10. Read number 9 for us, if you would, Kyla.
The sum of 2 consecutive odd integers is greater than 36.
Consecutive odd integers. How many of them were there?
2.
2. All right, so how do we represent any odd integer, class?
2x.
Thank you, Kyla. Any odd integer is going to be 2x plus 1. Guaranteed even with the 2x, add 1 guarantees it odd. Then the next consecutive odd integer is going to be, class?
2x plus 3.
There we go. And it says that the sum of these two consecutive odd integers is greater than 36. So Kyla, how do I write this?
Like the equation?
Yeah. Well, inequality, technically.
I did 4x plus 4 is, make sure I'm doing this right, is greater than 36.
There we go. Just add them together. 4x plus 4 is greater than 36. And then we need to solve to find out what these odd integers are. We're going to start by subtracting away the
The 4.
to get,
32.
and then
Divide everything by 4.
to get x is greater than
8.
8. Now, if x is bigger than 8, class, then we have to plug in something greater than 8 right here, which means we end up getting greater than 8 times 2,
Oh, 16.
16 plus 1.
17.
We get something greater than 17 for our first odd integer. And if our first odd integer is greater than 17, then class, the next odd integer has to be greater than
19.
19. So what are my consecutive odd integers? Something greater than 17 and 19. So kind of a weird, but same type of thing we did before, but with an inequality versus the equation. Does that make sense? All right, look at number 10. And read that for us, if you would, Everett.
Tractor trailer's maximum load is 32,000 pounds. If it is already carrying a forklift that weighs 8,200 pounds, how many 250-pound pallets of sod can it legally carry in one trip?
You sound really exhausted.
I am.
Didn't you sing one song yesterday? 2 songs yesterday. That's all you did all day, right? Was sing 2 songs?
We got back at like 9 because we almost got in a wreck.
Oh, who was driving? Pastor Adam?
Yes, sir.
We did pray for you guys because we knew he was, well, I thought he was driving. We did pray, Lord, protect him.
Well,
I
they
didn't
were
fast
like
though.
closing
Maybe I
off this
should.
road, but they had no warning, so he almost ran into whatever was like trying to block the road.
So he didn't almost hit another car, he just almost hit the
Yeah,
barricade.
Yeah.
Which still would have been
Crashed.
sad.
Yeah.
Very sad.
Everybody just kind of went, wow.
Who were you sitting next to at the time? Just kidding. Oh, never mind. Anyway. I don't know, just thinking back on high school days. All right, anyway, so you gotta plan things better than that, man. Just kidding, there's nobody here, right, that you're into, right? Oh, never mind. This is on YouTube too. It's okay, most of you don't know him. Number 10. We did some problems similar to this yesterday, or a problem similar to this with an elevator. yesterday that had a maximum load. And this particular tractor trailer, we talked about the big semi truck, right? Has a maximum load. And it's got a forklift on the back. How many have seen those sod? They're a flatbed tractor trailer, not the big box tractor trailer, but the flatbed. And there's a forklift stuck on the back, and then it's got just pallets of sod. That's what we're looking at here. Okay, they have to have the forklift because like something's got to unload the sod, right? So the forklift already weighs 8,200 pounds. So we want to load up pallets of sod. The typical pallet of sod is going to weigh 250 pounds. How many pallets can they put on this thing? How would we set this up as an inequality? If we remember that the maximum load is 32,000 pounds. What do you think, Everett? Well, what does maximum mean? Let's start with that.
Less than or equal to?
Less than or equal to. So something, the load as a whole, whatever it is, has to be less than or equal to
32,000.
All right, now what is the load? There's two things that in the load.
8,000. Well, it's carrying 8,200 pounds.
Of what?
Oh, wait,
The 8,200 pounds is a Thank you, Kyla. It's the
Forklift.
forklift. There we go. It's the forklift. So the load consists of a forklift and a whole bunch of
the 250-pound pallets.
the pallets, right? So you got the forklift,
Okay.
plus you got the pallets. Now, the forklift, we already know.
It's 8,200.
Yeah, there's no mystery on forklift. And the pallets, every pallet is 250 pounds. The question is how many pallets? Since we don't know the number of pallets, we call that,
250x.
well, X. So therefore, the weight of all the pallets would be,
250x.
and there's our inequality. Kyla, did you have that for your inequality? So to solve, we got to do what here, Everett?
We have to get rid of the 8,200.
To get 250x is less than or equal to,
Hold on. Does anybody got a calculator?
Do you want me to give
you have a brain. Kyla also has the answer already,
Is
though.
it 238,000?
How about 23,800? Use your commas. 23,800.
Oh, I had an extra zero.
Uh-oh. Yeah, we don't want extra zeros. You had a whole lot of
I
pallets
did
then.
use my commas, but I just added an extra zero. But I did.
You almost said I used my calculator, didn't you?
No.
Oh, okay. I was thought, did we just get a confession? Her face looked really ashamed for a
No.
moment there.
I used the comma. I just added an extra zero.
I'll say this in like the Catholic priest going to confession. Sit down, my child. Tell me, what sins have you
I
committed?
was second guessing myself, so.
All right. Now what do we need to do? Back to Everett.
You gotta divide the 250.
Divide it 250. But Everett, I don't want to divide it 250 because that's a really big number. I can make this easier by knocking off a pair of zeros. So now I'm just dividing by 25. Now, Everett, how many times would can 25 go into 23? No. So we need 25 into 238. Let's make a guess. How many times do you think it could go into 238?
I always start off with 6.
Well, let's start off with something even smarter, because if this were 250, how many times could 25 go into 250? 10. 25.
Oh, wait, yeah.
10, right? This is almost 250, so that means it wouldn't go in quite 10, but it should go in
7.
Oh my.
Nice.
9. Almost 10 would be 9, right?
Yes, sir.
For the record, if you're watching on YouTube, I did not teach him division. This is my first year with him, okay? Don't blame me. All right.
Can I say something?
Sure.
Never mind.
We love you, Everett. Okay, so anyway, yeah, so that's the way I like to think of it. It's like, does 25 go into 23? Almost, just not quite. So when I go to the next level, it's like, well, this is almost a 250. That would be 10. It goes in 9 times. Now, you can do this on your paper. What's 9 times 25? Yes, paper, but no pencil. You sing 2 songs and you just forget everything.
Yeah, actually, that's literally what happens.
Yeah, so I see.
Yeah, I forgot my tournament.
Confession is good for the soul.
Okay.
Didn't I just help you get an article the other day? I thought you already had the tournament.
Oh, that we do 2 tournaments.
Oh, okay. Anyway.
So what were we doing? 250 times 9?
25 times 9.
Oh.
I remember we knocked off the 0 so we wouldn't have to divide such a big number.
Yes, 9 times 5
I had
is
it right.
45.
Double checked.
245.
There we go. You could also think, Everett, 9 quarters. 4 quarters to $1, 4 more quarters to another $1, and then 25 cents more. $2.25. When we subtract Everett, what do we get?
You get 3, then you get 1, and then you get nothing.
Right, so then we bring down the 0. Now think quarters, $1.30. If you had to give $1.30 in change, how many quarters would you give? How many is that?
5.
5, okay. Most people hold it up like this instead of like this. So I was like, is he trying to say 14 quarters? Okay, 5. Because 5 times 25 cents is how much money?
It's $1.25.
$1.25. That leaves me with 5 left. If I add a decimal, bring down another 0, how many times 25 go to 50?
2.
2. All right, so that means that the total division here would be 95.2. This truck can have its 8,200 pound forklift. Like, we were talking about forklift? Yeah, forklift and sod, remember, it was a long time ago? And we said, how many pallets of sod, if they're 250 pounds apiece, could this truck legally carry? Less than or equal to 95.2 pallets of sod. More realistically, Everett,
96.
oh, the pain, less than or equal to 95.2? Is 96 less than or equal to?
No.
No.
I swapped it. It's 90.
There we go. Now, if it's a greater than or equal to, if it had to carry at least, I don't know why it would be this way, but if it had to carry at least 3,200 pounds, maybe we live in a world of reverse gravity. And if you don't load it up enough, it's going to float off the road. Then you'd have to round up and say 96. But this is a maximum load, not a minimum load. So we'll round down and say 95 pallets. No more than. Maximum of 95 pallets. Is that what you had, Kyla? Good job, Kyla. Every question? Hang in there, man. We'll get there. Let's turn over to page 148 now. That took a lot longer than I thought it did. That's okay, though. You know what I'm saying? It's okay. Page 148. I mean, Zach is laughing at you, and Curtis is rolling on the floor. But, you know, Rebecca doesn't hate you, though.
She's probably laughing too.
She's laughing too? I don't know. Very quietly, though. Very quietly. Discreetly. All right.
Hey.
It's true. He's like, but Mr. Dasky, I got 2 perfect exams on the wall of fame back there. It's true. In his defense, because this is the first time YouTube has ever been exposed to Everett, lest you think he's a stupid idiot. He is not. Okay? He's an A student and he's got 2 perfect tests on the back wall. So, which I don't think anyone else in here has a perfect Algebra I test yet. He's got 2 of them. So he is smart. He's just, his brain's just off today. He sang 2 songs, and that really did it. He was traumatized by Pastor Adam's driving. There we go. We knew there had to be a logical explanation. Blame it on Pastor Adam. Oh, Pastor Adam, I may never forgive you for this, what you did to me. Through Everett. All right, anyway, we're on page 148. I'm having way too much fun with this. Page 148, and you did numbers 1 through 8. There in the middle of the page, the review 4.7. And Kyla, number 1, what did you have to do at all 3 spots?
Subtract a 3.
Subtract a 3 to get what for your answer?
Negative 1 is less than x is less than 2.
Negative 1 is less than x is less than 2. Very good. Number 2. Well, what did you have to do for this one? Everett.
We're
In the middle section. The review 4.7. Yeah, I just said that.
You have to add a 1.
You do have to add a 1 everywhere to get what?
Negative 2 is less than x is less than 5.
Very good. Negative 2 is less than x is less than 5. Number 3, what do we have to do everywhere? Kyla.
Divide by 3.
Divide everything by 3 to get?
1 and 2/3
If you want to do it that way.
is less than x is less than 2 and 2/3.
All right, yeah, and I will say this. If you are graphing the solutions on the number line, I would prefer to think 1 and 2/3 is less than x is less than 2 and 2/3. Because let's be real, 5/3 is less, where on earth do I graph 5/3? Where on earth do I graph 8/3? But 2 and 2/3 well, it's annoying enough, frankly. But your 1 2/3, well, that's going to be right around here. And your 2 2/3 is going to be right around here. And so you shade everything in between in that little spot. So for graphing purposes, absolutely, mixed numbers help. I didn't actually require the graphs. Did you do the graph? You did. Look at you. Great job there, Kyla. What a great student. I'll send the link to your mother. Actually, I'm for Curtis anyway, because he needs to see this. Mainly because of what's coming next. But anyway, after he suffers through this part. Blame Pastor Adam. Blame Pastor Adam, Mom. All right, number 4. In case you're wondering, I have brothers in the class. There's a Curtis and an Everett, and they're brothers. Anyway, one of them's gone today, and one of them was gone yesterday. Anyway. Number 4, what do we need to do? Everett?
Divide everything by 4.
To get?
The negative 5 over 4 is less than x is less than 2.
Good. Negative 5/4 is less than x less than 2, or negative 1 and 1/4 is less than x is less than 2. By the way, real quick, negative 1 and 1/4, as Kyla checks her graphs, the 2, of course, no big deal. But the negative 1 and 1/4 would be right around here, just a little further left than the negative 1. And then, there weren't 4 equal 2's, right? No, no equal 2's. All right, number 5. What do we need to do, Kyla?
Divide everything by -2.
Now, I see, I was just proud of you, and now I'm ashamed because it's sloppy.
But
Ready?
I read it.
You still read it. Okay, divide everything by -2. And when we divide by negative, we reviewed this just a little bit before we started the video. What do we have to do, Everett?
We have to
Flip them all around. So, Kyla, when we divide the -2, what does it give me initially?
2 is greater than x is greater than -3.
But we can't leave it this way. We got to then flip the whole thing around and make it say.
-3 is less than x is less than 2.
There we go. Good. Question on that. Because you got the next one. Number 6. What do we have to do, Everett?
We have to divide everything by -3
To get, initially,
to get 3 is greater than x is greater than 2.
well, we're dividing -3,
Yeah,
so
so -2.
-2. He's trying to do it in his head there. And then we got to flip the whole thing around to make it say.
-2 is less than x is less than 3.
There we go. Excellent. Hopefully, Zach, Curtis, Rebecca, you remember doing this yesterday. We're in the last lesson in Zach and Rebecca's case, since they're having to do both of these by way of video. Number 7. What do we need to do, Kyla?
Add a 1 to all the areas.
And once you've added the 1 everywhere, then you follow that up by doing what?
Dividing everything by 2.
And what is your answer?
-2 is less than x is less than 4.
-2 is less than x is less than 4. Number 8, 2 steps. First, we need to do what, Everett?
Subtract the 2.
To get initially,
-3 is less than 3x is less than 6.
and then
We have to divide everything by 3.
to get.
-1 is less than x is less than 2.
There we go. All right, questions on the homework. Kyla, good to go? Everett, questions?
Yeah, I'm good.
All right, flip over to page 456. Let's begin exam review now. Do have our exam coming up on Tuesday, and we won't have time Monday to go over this. Obviously, Monday's the big review lesson, including, by the way, that word problem handout. We'll be going over that on Monday, so make sure you have that finished by Monday. But for now, page 456, at the start of this quarter, we began by working on fractions, rational expressions. And we haven't really done a lot with them in the last few weeks, but I want to make sure we remember what we're doing. So page 456, let's go over some of these problems. For instance, problem number 1. Problem number 1. It tells us to do what, class? Add those 2 expressions. Add those fractions. But class, you can't add fractions unless you have a common denominator. And right now, do we have a common denominator? No, x plus 1 is not the same thing as x plus 3. In fact, I said when you have polynomial denominators, you have to do what with them? Either
What is that called?
factor or group. When you have polynomial denominators, class, you either need to,
Factor.
well, can I factor this?
No, sir.
So I group it. Can I factor this?
No, sir.
And so I group it. Once we've factored or grouped all our denominators, we're ready to actually start the process. And I said we start adding fractions by drawing a
Big long line.
big long line. Underneath the big long line, we got to figure out the LCD, that least common denominator. And I said we represent all of our winners. Well, is x plus 1 a winner, class?
Yes, sir.
Yeah, by forfeit. Nobody else competed. We didn't have any of those yesterday in fine arts, did we? Any like forfeit wins where we were the only group there?
Technically, there was one.
Which one?
Michael Mills.
Michael?
Yeah, he did turn in his photos because he just didn't want to do it. So kind of.
Oh, no, I mean, we win something where somebody, like the others, nobody else competed in that category, so our person won.
Oh, yeah.
No, none of that. Okay. Well, x plus 1 won because no one else competed in that category. What about x plus 3? Is that a winner?
Yes.
That's also a winner. They're both winners because there's nobody else there. So then remember, we look at the denominator and say, this is what I want. This is what I got right now. What needs to change to make this become that? Class? Multiply by x plus 3. But what we do to the bottom. And so what do I copy above the big long line, Kyla?
3x plus 9.
Similarly, on the next fraction, what am I going to have to do, Everett?
You have to multiply by x plus 1.
In both
Bottom and top.
bottom and top to get what above the big long line now, Everett?
5x plus 5.
My next step, of course, just clean it up, make it look nice. Kyla?
8x plus 14.
There we go, all over the x plus 1, x plus 3. I said if we can factor, we could factor out a 2, couldn't we? But would pulling out a 2 help me cancel anything? So I don't want it. If I could cancel some, then I factor, but I mean, 4x plus 7 is what I'd have. We can already see that. That doesn't help me, so we'll leave it just like that. Do we remember adding fractions? Getting the common denominator, drawing that big long line questions on number 1. Drop down to number 5. Here we have a complex fraction. Remember, a complex fraction is just a division problem. But you have to have a single fraction over a single fraction. Well, right now I ain't got a single fraction. I've got 2 different terms up here. So remember, here's where we draw our sort of big long line in the top. And underneath it, what goes under that sort of big long line, class?
2x.
2x. Now, right now, this is a 1 over 1. I've got a 1, I want a 2x, multiply top and bottom, class, by
2x.
2x. Here, I got a 2x. Well, that's what I want is a 2x. This is already exactly what I want. So, class,
2x. Well, it's
change nothing, right? I mean, you could say multiply top and bottom both by 1, I guess, but you don't need to change anything. So what do I copy above the sort of big long line?
2x.
2x, and then a negative 1. At your seats, do the denominator of the complex fraction. At your seats, set up the denominator of the complex fraction. Is this what you have? Any questions on that? Now that we've got a single fraction over a single fraction, now we can do what the complex fraction tells us to, class, and that is to divide. But do we really divide fractions? No, we multiply by the reciprocal. So I'm going to rewrite it now as a multiplication problem. Kyla?
2x and then divide over 2x times x squared over 4x squared negative 1.
And remember, in a multiplication problem, we want to factor everything we can because we want to try to cancel everything we can. We're not interested in any common denominator in a multiplication problem. We just want to cancel stuff. So any polynomial, not just denominators. With addition, all we focus on is getting that LCD. All we care about is factoring or grouping denominators. Here, I want to factor or group any polynomials I see. So like 2x minus 1, class, I should group it. That's not a polynomial. That's not a polynomial. Ah, this is a polynomial. What do we want to do with this? Yeah, this is what right now, class A? Difference of squares. Good, we can factor it into, as she said, a sum and difference. What is that sum and difference, Kyla?
2x plus 1 times 2x minus 1.
There we go. And now that we've factored, now we can cancel. You don't cancel anything. Don't try to cancel those two x's. Because that's not a 2x, it's a 2x minus 1. That's a 2x. They don't cancel, they're not the same. But I can cancel what, Everett?
The 2x negative 1 with the 2x.
Those actually match. And there's one more thing I can cancel.
Oh yeah, an x. And an x on the top, just so that just x.
Good, this x with the x squared to get just an x up here. So what is left for my answer now? Class?
X over 2 times 2x plus 1.
All right, and we did cancel stuff, remember? So we got to say, for instance, this x that canceled, class, cannot equal 0. And this 2x minus 1 that canceled means that x also cannot equal, class,
1/2.
positive 1/2. As we move the 1 over, divide by 2, and I think I may have cut that off just a little bit. Nope, just fit it on. Okay. Do we remember? Complex fractions, division, multiplication of fractions, all that stuff. Remember that. All right, drop down to number 13. What if I just want to reduce fractions? Well, it's similar to what we just did, class. To reduce fractions, I have to first factor, and then
Wow.
cancel.
That's the word.
It is the word. How do we reduce fractions, class? 2 steps? Factor and cancel. How do we factor that numerator, Everett? Number 13.
You can, you can pull out a 4.
On number 13, the numerator?
Oh, the numerator. I'm sorry,
Yeah.
I was looking at the denominator. My bad. You can pull out 15.
Pull out a 15 to initially get.
You can get x squared minus 1.
And, but that's special. We can factor that again into,
That's the difference, which is x plus 1x minus 3.
there we go, difference of squares factoring into that sum and difference. In the denominator, Kyle, how would we factor?
You pull out a 12.
Good. Pull out a 12 to initially get.
X squared.
Well, careful, 12 out of a 20.
2x squared.
There we go, 2x squared.
Plus x minus 3.
There we go. And then it looks like we should be able to factor a little bit more using some backwards FOIL.
Why did I just forget to do backwards FOIL?
We'll start by splitting up your 2x squared because it's a Friday.
2
That never is contagious.
2x times x.
2x and x, the signs.
I got rid of these.
Wow. Just, sorry.
A negative tells me my signs are going to be same or different. Different, right? Because a positive, it comes from having same sides, same signs. So we have a positive and negative. The only way to split up a 3 and 1, or 1 and 3, we always check the outer inner, remember. If I check the outer inner, does that actually work?
Wait, yes.
Yes, we got it on the first try. That doesn't always happen, but it's awfully nice when it does. Now we're ready to cancel stuff. What can I cancel, Kyla?
And x minus 1.
With another x minus 1. And there's actually one more thing we can cancel. Everett?
Is 3 out of 15 and 12.
To get.
5 and 4.
So our reduced answer is going to be what, Everett?
5 times x plus 1 is over 4 times 2x plus 3.
And we do need to specify, since we canceled the x minus 1 class, that x cannot equal positive 1. Look at number 14. Actually, for sake of time, we are not going to have time to factor that, but we would pull out a 2 in the top, and then we would, 2x in the top, then we'd backwards FOIL. In the bottom, we would pull out a 4x squared, and then factor a sum and difference. We cancel stuff from there. Drop all the way down to number 18. Number 18 is a multiplication problem. We kind of already did one of these as we did the complex fraction. What's the key to the multiplication problem on number 18? Factoring everywhere, right? Numerator, backwards FOIL, x plus 4, x minus 3. The denominator, just pull out a 3 to get x plus 2. The next numerator, sum and difference, x plus 2x minus 2. And then that last denominator, another backwards FOIL, x and x, negative, negative 2 and 3. Right? So that's the key to multiplication. I don't care about common denominator. I care about just canceling wherever I can. And here I can cancel these, I can cancel those, I can cancel that. And so we're left with an answer class of just
x plus 4.
And what are my excluded values, Kyla? X cannot be.
Negative 2.
Do you remember doing that?
Yes, sir.
Drop right below it, or down below it off to the side, number 19. It's a division problem. Again, can't work with the division problem. Got to change it to multiplying by the reciprocal. So the first fraction stays the same. So in the top we factor out an x. And let's see, that's going to initially give us x squared negative 5x negative 6. Then we got to backwards FOIL that too, don't we? Thoughts?
X and x. Positive, negative. Hold on. 1 and 6.
Very good. Excellent. All right, and then the next denominator, we can pull out a 3 to get initially, x squared plus 3x plus 2. And Kyla, that can backwards FOIL.
X and x, positives, and 2.
There we go. And then we're going to change the division to multiplication. So moving up to the numerator is going to be the x squared positive x negative 2, remember, which we can then backwards FOIL that, Everett.
Oh, I'm looking at the wrong one.
Number 19, we're going to move that old denominator up to the top.
So you can fast forward to get x and x, positive, negative, 1 and 2. No. Yeah. Oh. 2 and 1.
Because we want the positive 1x in the middle. And then, Kyla, we're going to move the old numerator down, start by factoring out a? Number 19, the second numerator is moving down as a denominator.
Factor out 2 to get x squared negative 7x plus 6.
Good, and then we can backwards FOIL that.
X times x, negatives, and 6 and
There we go. And then, of course, we can cancel stuff. Class, we can cancel the
X negative 1.
x negative 1s.
Oh, I forgot about the other side. You can cancel the x negative 6.
X negative 6s. What did you say, Kyla?
I said the same
Same thing, okay.
X plus 2.
X plus 2s.
And x plus 1s.
X plus 1s. So what's left?
Oh, man. There's
X over
6.
6, because there's a 3 and a 2 left. So x over 6, where the x can't be, negative 2, negative 1, positive 6, positive 1. And there'd be our answer. One quick reminder, let's suppose there had been like another x right here. Let's just suppose in the old denominator, we've looked it up, there'd been an x. Well, that means we get an x squared right here, wouldn't we?
Yes.
This x didn't cancel, but it would have flipped out of the denominator, wouldn't it? In that case, we would have also said x can't be 0. That's the one little last detail to remember with division, is if it flips out but doesn't cancel, and both of these did, we got to make sure we include that as an excluded value. That's kind of our crash course, review of fractions. All right? Your homework for the weekend is to complete that word problem handout. We'll be going over that on Monday. We'll be reviewing for your exam on Monday, focusing primarily on chapters 3 and 4. And then Tuesday is your exam. Get some rest this weekend and get your brains recharged. All right, Zach and Rebecca and Curtis, looking forward to having you back in class Monday. Hope things went well at Fine Arts.